everyone. My name is Ava Perone, and I'm currently a PhD candidate in the Department of Electrical Engineering and Computer Science here at FAU. Today, I'll be presenting a brief update on my dissertation progress, including the work I've completed, what I'm currently working on, and the next steps in my research. Before I begin, I want to give a quick background about me. I graduated in 2022 with a bachelor's in computer science and a minor in AI. I graduated again in 2023 with a master's in data science and analytics. I passed a qualifying exam in fall of 2023, and I became a PhD candidate in the spring of 2024. I work full-time as of 2023 at L3Harris Technologies as a software engineer, and I am a part-time PhD student. My academic interests are centered around the application of machine learning in healthcare, particularly in predictive modeling for events like stroke, heart attack, and sudden cardiac death. Over the past 2 semesters, one of my major milestones has been completing and submitting my literature review paper. The review explores how machine learning can be used in stroke diagnosis, stroke prognosis, and heart attack prediction. During the fall semester, I focused on completing and revising the paper, incorporating structural changes, recent studies, and clarifying key distinctions in methodology. In the spring, I submitted my paper to a journal from which I received detailed feedback from journal reviewers, and I completed the revisions and resubmitted the final version. In parallel, I also obtained the dataset that I would like to use for dissertation research, which includes ECG, clinical, and demographic data from chronic heart failure patients, and I would like to use that to predict SCD or sudden cardiac death. Some of the key findings from my literature review. I found many patterns and limitations in the methodology that point to opportunities for improvement. First, many of the studies relied heavily on small data sets, which is due to the fact that there is difficulty in obtaining data sets, especially in the medical field, but this generally reduces the generalizability of the findings, and it makes it difficult to apply the models in a real clinical setting. In addition, only a few of the studies addressed class imbalance effectively, which is a critical issue in data sets in medicine, where positive cases such as stroke and cardiac events are underrepresented, and if this is not handled properly, it can lead to biased models that will not perform well on the minority class. Another observation was the limited use of performance metrics. Most studies reported only accuracy or accuracy in one other, which doesn't provide a full picture, especially if the data set is imbalanced. So for more robust evaluation, metrics like AUC, sensitivity, precision, and F1 score should be used. Otherwise, you might not create a credible model assessment. And lastly, some of the studies did not use control groups or real-time testing, which can limit their relevance in the real clinical field. Some gaps in the research. A few papers experimented with natural language processing to extract features from clinical notes, which shows promise for improving models. However, there's still a lot of work that can be done there in terms of the methodologies used. I also noticed that many studies used CT scans or MRI scans, but the two were never compared. CT scans are a lot more common in emergency settings, while MRIs have advantage in tissue contrast, so it would make the issues more clear to clinicians. However, a balanced comparison between the two is needed um, to determine which could be more useful um, for this type of classification. I also found that mobility features like physical performance and imaging data could be effectively combined in multimodal machine learning models. So there's definitely room for more research in that area. Um, Additionally, concepts like explainable AI and transfer learning, which are crucial for making models interpretable and generalizable, remain underexplored in this domain. These gaps will help shape the direction of my own research, where I plan to apply a multimodal approach that incorporates diverse data and a more rigorous evaluation. At the moment, I'm developing a research paper proposal which centers around using multimodal machine learning to improve prediction of sudden cardiac death in chronic heart failure patients. I'm in the process of refining my research questions and objectives with a focus on integrating ECG, clinical, and demographic data. I'm also reviewing recent work on multimodal fusion strategies and model evaluation frameworks to help my methodological approach. The next major steps will start with finalizing the proposal, and then I can start pre-processing my data set. This will involve cleaning and organizing ECG, clinical, and demographic data. Um, and then once my data is prepped, I'll be able to train baseline models using individual data modalities, and then move on to building multimodal models that combine these inputs. Alongside that, thank you for your time, and I appreciate the help that you are all providing me in my process.